All right, so now we finished up binomial times binomial there. So let's do this one, which is going to be a trinomial times a trinomial. Even more complicated, all right? So there's a way to line this up, honestly, to kind of help yourself a little bit. So I'm going to teach you that. So you want to do w squared times each of these, right? So you're going to have w squared times, oopsie, times w squared. Now you're going to do w squared times minus 5w. So plus, oopsie, screwed that up, plus w squared, oh, I'm going to have to write that, w squared times minus 5w plus w squared times minus 2. There's the first one. Now notice that front term, that's a w to the fourth, right? Okay, so keep that in mind because it's going to help. Now I'm going to do 2w times this w squared business. Okay, so that's 1 plus 2 more makes 3, which if you'll notice lines up with this term right here. There's 3 of them there. So I'm actually going to line it up right below it and say plus negative 2w times w squared. Okay, kind of got it lined up. All right, then let's see here. Minus 2w times, so plus minus 2w times minus 5w, that's the next one, plus minus 2w times minus 2. Of course, the way I'm doing this is not going to be beautiful, but you know, it gets the job done. Okay, so then, last but not least, I'm going to try the third one. So notice the first guy gives me 3 terms. I got the w squared times w squared, that's one term. Then it gives me w squared times minus 5w, that's the next one. And then it gives me w squared times minus 2, so that's 3. And then the negative 2w gives me one term. Then it gives me another term. And then it gives me a third term, right? And then the last one's going to give me 3 as well, because you have to multiply each one of them by 3 things. So my last one's going to give me 3 terms. Oops, there you go. I had to pause to fix some things there. Okay, so it's plus 4 times w squared plus 4 times minus 5w plus 4 times negative 2. Now I know what you're thinking. You're thinking, Alana, this is not simpler. Oh, but it is. Let me just show you here. This one, the way I've written it here, is going to line up with this guy right here. And they're both w to the third ultimately, because you have a w times a w squared. So these two are actually like terms, and they're lined up vertically one over the other. And then this one right here with the w squared, notice that's got a w squared, he is right over another one that's w squared. So you have minus 5w times minus 2w. That's also a w squared, right? Let me underline it so you can see it vertically a little bit. And then that's right over this 4w squared right here. So those 3 all line up. Okay. And then I kind of push this down a little bit so you can see. And then the 4w, or excuse me, the 4 times 5w and the 2w times negative 2, those line up. See it? So if you vertically align yourself, you can actually make things a little bit simpler to figure out. Cool, huh? All right, so let's finish it out. We only have one more step and we're done with this, believe it or not. Okay, so let's see it. All right, in the front, we have a w squared times a w squared. That makes w to the fourth because you add the powers. Oops, I think I pressed my caps lock button. There we go. Plus, okay, this is minus 5w cubed minus 2w cubed. So minus 5 take away 2 is minus 7w cubed. All right, now the 3 that have the double underlines, they're the hardest. You have a minus 2. You have a positive 10, because minus 2 times minus 5 makes plus 10, plus 4. So 14 take away 2, so that's 12. So plus 12 w squared, because all three of those were w squareds. All right, then let me see if I can get these two. I have a minus 2 times a minus 2. That's positive 4, right? Kind of give them a double arrow so you can see it. And then I have plus 4, so for that one, and then a minus 20 for the next one. 4 take away 20 makes minus 16w, because both of those just have w's. And in the end, it's minus 8. And we're all done. All right, so that was a trinomial times a trinomial. Those ones, it really helps if you line them up. I mean, you actually can do the lining up thing on these other ones too, but the trinomial times trinomial, it's really nice. All right, I'm going to throw in another example here. Hold on, let me pause this. I'll be right back. There we go. I just kind of threw this one in there because I thought, we need to get a couple harder ones. And the trinomial times trinomial is tricky, but let's add this in. Now, this is a little bit complicated because this is really a monomial times a binomial, which is this one, times a trinomial right here, right? So let me write that up. All right, there we go. So like I said, it's a monomial times a binomial times a trinomial, so we got all sorts of things going on. Now, what I would recommend, I mean, you can do this a couple ways, but I think it would be easiest to tackle the hard parts first and leave the 3x kind of to the very end. So I'm going to write 3x in front. All right, now what I'm going to do is I'm going to do 2x times each of these three items. So 2x times x squared. All right, and this is where I kind of let you know that it starts getting annoying to do that all the time to write it out. So we start doing it in our heads a lot. 2x times x squared makes 2x cubed minus 2 times 10 is 20. So minus 20x. Oh, hold on. All right, fine. I'll write it out this one time. All right, 2x times negative, oops, sorry, you don't like that, times negative 10x. I'll deal with that in a second. Oh, it's plus 2x times negative 10x plus 2x times, let's see, 5. Then you have minus 4 times x squared minus 4 times negative 10x minus 4 times 5. You can see it just gets so annoying because it's 2x times each of these three things, then minus 4 times each of these three things. And it's easier just to do it in your head. 2x times x squared makes 2x cubed. Oopsie. 2x times negative 10x makes negative 20x squared because there's two x's there. X times x is x squared. Then you have a plus 10x because 2 times 5 makes 10. Then you have a minus 4x squared. I mean, you don't have to write it out. It's 4 times an x squared makes 4x squared. And then minus 4 times minus 10, that's the hardest one. Minus times a minus makes positive. So that's positive 40x minus 20. Now combine some like terms in here. 3x times 2x to the third. All right, negative 20x squared minus 4x squared makes minus 24x squared. Plus 50x minus 20. All right, so all of that was to do the binomial times the trinomial part, and it's all done. Here we are. Now I'm going to take 3x to each one of these, and I'm just going to do it in my head here. 3 times 2, because you're multiplying all of this, right? It's 6x to the fourth, because remember we add powers. X to the 1 times x to the 3 makes x to the 4. All right, minus 72. Yeah, 72x to the third plus 150x, because 3 times 50 makes 150, minus 60x. Oops, that's x squared. Typo. There we go. Because there's an x here and another x here. When you multiply them, you add the powers and it gives you x squared. Okay? So that was a more complicated problem than the one that we had on the page. And we're all done with it. All right, so let's move on to try to get this done in the next few minutes, which is finding the product here. So we have x plus 6 squared and 3k minus 4 squared. So let me tell you what students always want to do. They always want to do this. Oopsie, sorry. And they want to go, oh, that's x squared plus 36. No, 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 no. This is totally wrong. Don't do that. Okay, the deal is when you multiply, or when you have something to the second power, what you're doing is you're multiplying it by itself, right? So you need 2 of them in there. Okay, but we learned that when you do that, you have to distribute. So you take x times each one of these. So you take x times, hold on, I'll write it out. X times x plus x times 6. There we go. Plus 6 times x plus 6 times 6. I know I'm writing it all out, which I normally don't do. But that's x squared plus 6x plus 6x plus 36, which means it's x squared plus 12x plus 36. You can't just distribute the power. You have to distribute each term. So in other words, you have to FOIL, right? Hold on. There we go. We need to FOIL. All right, so let's do a more complicated problem. What if it's 3k minus 4 squared? So 3k minus 4 quantity squared would be equal to, and for the love of goodness, write it out, right? If you write it out, you won't forget, right? So it's 3k minus 4 times 3k minus 4. That's equal to, and I'm going to start, like I said, not writing everything down. 3 times 3 is 9. K times k is k squared. Minus 12k, because outers, 3 times negative 4 makes minus 12. Inners, minus 12k again, because 4 times 3 is 12, plus 16, which makes 9k squared minus 24k plus 16, like that. Okay. And again, we start just doing everything in our heads and stop writing every single step down because it gets really tedious. All right, I'm sorry I had to pause it, but even though I didn't have this in there, I'm going to throw in an example C, which is a little bit harder, okay? So I'm going to take 7x squared plus 8y squared. I'm going to square the whole thing. Okay, so what's that going to look like? It's 7x squared plus 8y squared times itself. So you have 2 of those, right? Because when you square something, you're multiplying by itself. All right, so 7 times 7 makes 49. X to the 2 times x to the 2. You add the powers and becomes x to the 4. Plus, all right, now I'm going to take 7x squared times the back term, which is 7 times 8, which is 56, x squared, y squared. Plus another 56, because I'm going to take 8 times 7 this time. So 56, y squared, x squared. And again, the order there doesn't really matter. Plus 64y to the 4th now. So this is equal to 49x to the 4th plus 112x squared y squared, because you're going to add these 2 in the middle because they're like terms, right? They're going to combine together, plus 64y to the 4th. And we've learned a valuable lesson, which is when you take a binomial and you square it, did you notice how the middle always becomes the product of those middle terms? So 3 times 4 times 2 makes 24. 1 times 6 times 2 makes 12. 7 times 8 is 56. 56 times 2 is 112. And that's what the little box is going to say. Poof, there it is. So that the middle term is always 2 times a times b, or minus 2 times a times b. That works out every time it's a square of a binomial. You get that with a special trinomial, and that trinomial is so special we give it its own definition. It's called a perfect square trinomial. It's trinomial because there's 3 terms, 1, 2, 3, and it's perfect square because it's the perfect square of this binomial. So anytime you take a binomial and you square it, you end up with a perfect square trinomial. 3 terms, but they were made by perfectly squaring some binomial somewhere. Right? And that middle term always ends up to be double what a times b is. Just a little definition stuff for you.